In this video, we're going to use a slightly less frequently used definition of the derivative to take some derivatives using fractions and square roots. Now, I'd suggest you watch the organic chemistry tutor video on using the limit definition of the derivative, which goes through both of these using the more standard definition. So we're just going to also do them using this new definition. So let's go ahead and see what that looks like. So we're going to have the limit as b approaches x. Really, I could have written b, or I could have written a. I've used z in the past, but z just looks like 2, so let's not. So we're going to have f of b. I'm just writing out the definition over b minus x. And what does that equal? Well, that's going to be the limit as b goes to x of 1 over b minus 1 over x over b minus x. Let's go ahead and find a common denominator here. This is going to be the limit as b goes to x. I'm going to multiply this one by x over b, and this one by x over x, this one by b over b. That will get me x over bx minus b over bx, all of that over b minus x. I can go ahead, I'm going to do 2 steps here. In fact, we'll write out one of them here. We can go ahead and put those fractions all together. So we have x minus b over bx, all of that over b minus x. I can now write this as multiplication by a reciprocal, because that's how we divide fractions, as we multiply by the reciprocal. So this is x minus b over bx times 1 over b minus x. And I can notice that x minus b is the same as negative b minus x. I'll go ahead and write that. If you change the order of subtraction, you just get the negative. So I can write this as negative b minus x, all in parentheses, over bx times 1 over b minus x. Cancel out our b minus x's, and we end up with just the limit as b goes to x of negative 1 over bx. That, of course, we can evaluate. That will just end up being negative 1 over x times x, which equals negative 1 over x squared. So we get the same answer. I personally like this way a little bit more because I don't have awkward x plus h's floating around. Those x plus h's are useful when we're like squaring stuff like that. But I think they're a little bit, especially when you're dealing with fractions, this can be a little bit easier to work with. So let's go ahead and go to the square root version, see what that looks like. This will look very similar to the other approach, but we'll at least see what happens. We'll have the limit as b approaches x of f of b minus f of x over b minus x. That's going to be the limit as b goes to x of square root of b minus square root of x over b minus x. This is where we want to multiply by by the conjugate to clear our square roots. At least clear the square roots in the numerator, because that's where we have our problem. When we do that, the numerator just ends up being b minus x. Using our difference of perfect squares formula, this is just b minus square root of b squared minus square root of x squared over b minus x times square root of b plus square root of x. We see that the b minus x's cancel. Remember that there is always an invisible 1 floating in the numerator, so we don't end up with 0. It's tempting to write 0. But this is really just 1 over square root of b plus square root of x, which we can then plug in x for b. That's going to be 1 over square root of x plus square root of x, which equals 1 over 2 square root of x. And again, I just find this formula a little easier to work with here, but it's up to you, whichever one you feel more comfortable with. So there you go.